This time we'll be dealing with rational inequalities. Okay, so when dealing with inequalities, the first thing to do is to isolate everything to one side. So by that, we'll be moving 1 out here to the other side. To do that, we will be technically subtracting 1 both sides. So we'll obtain here the following. Okay, so now from here, you might be wondering why I left some space out here. The reason for that is we will combine these two into a single fraction. So to do that, we will be multiplying here x minus 2 all over x minus 2, and so that we will have the same denominator out here. So again, combining these two, we will obtain the following. Then from here, let's just simplify. So take note that for this one, we'll be having x minus, let's distribute the negative inside the expression, so we'll have x minus negative 2, or that's plus 2. The x's out here will be 0, so we'll just be left with 2. Doing this one out here, we will obtain, so what we did here again is simplify. So let me just move this one out here. And then from here, observe that this thing is just a constant, positive constant. This means that the sign of this whole inequality is just dependent on this denominator out here, which means that all we have to check is x minus 2 less than 0. And from here, you might be wondering why the equal to was omitted from this part. Basically, that is because when this one becomes equal to 0, then this thing becomes undefined. Just to emphasize, this is an important step out here. Let me put an exclamation mark out here, and let me put a y out here, so that you will remember the reason behind that. These two are not the same inequalities, but they yield the same result. So we just consider and simplify the case to this. Finally, solving for this linear inequality, all we have to do is to simply move negative 2 to the right side. Or technically, what I mean by that is we'll be adding 2 both sides. So that will give us x less than 2, or in interval notation, this is given by x in the interval negative infinity to 2. And this one is the answer for this first item. Let's move on to the second item. Like in the first one, the first step again is to isolate everything to one side, but fortunately for us, it's already isolated out here. All we have to do is to observe what happens in this. And in particular, since our goal is less than or equal to 0, then our goal is for this thing to be 1 equal to 0, so that is easy, we'll deal with that later. And the harder one is that whenever it is negative. So the best thing to do is to create table of signs. Let me construct that one first before I explain it. Okay, good. So there you go. So to explain this one, this first column represents the linear factors in our rational expression. So this one, x minus 7 and x minus 14. And then this last one out here represents basically what we want to determine the sign of. And then for this first row, top row, that represents basically the real number line. And we divide it into 3 regions. The first region is divided by 7. And then the next one is divided by 14. So you might be wondering, where did those values came from? Obviously, it might came from these two, and that is correct. Basically, we divide the region on the points wherein these two becomes 0. So we call those values the critical numbers. So in this case, we have 7 and 14. 7 because denominator becomes 0 at 7. 14 because numerator becomes 0 at 14. The most efficient way in dealing with table of signs is to first mark the parts wherein these two will become 0. So as mentioned earlier, for x minus 14, it would be this one. And then for x minus 7, it would be this one. Since out here represents the x equals 7, out here represents the x equal to 14. So why did we do that? Because like how I explained in the last video, the part wherein this becomes 0 actually marks the change in the sign of this thing. So just take note of that one. If you want a more in-depth explanation, you may check the previous video in this series. But applying that idea out here, all we need to do is to check the signs in the first column. So in particular, for this first interval, we can consider the test value 0. Let's write it out here. Negative infinity to 7 is 0. If we plug in 0 out here, we have here 0 minus 14. This first one will be negative 14, and that would be a negative sign. Next one, 0 minus 7, that will be negative again. So we'll have here negative. And then from here, we can easily determine the signs for the corresponding columns. So again, these two marks the change in signs. So for the second column, this will still be negative, and this one will be positive. Since no mark out here, but we have a mark out. Similarly, for the last column, we'll have here positive and positive. Since there's a change in sign out here and no more change in sign out here. Determining the sign of what we want, all we have to do is to check what happens when we divide this sign by this sign. So for the first column, a negative number divided by negative number will be positive. For the second one, negative divided by positive will be negative. And then for the last one, positive divided by positive, that will be positive. So again, since our goal is less than or equal to 0 of this one, we want the value that would make it negative. And that is precisely this interval out here. So between 7 and 14. Moreover, since we want it to be equal to, so that happens when the numerator is 0, or basically when we have x equal to 14. So let me shade this one out here. So this represents x equal to 14. You might be tempted to shade this one as well. But if this one is 7, then the denominator becomes 0, which makes this undefined. So this one cannot be part of our solution set. Therefore, we can conclude that the answer for this problem is, or in interval notation, we have pretty nice. So that is the answer for this problem. Good, so let's now move on to the last item. So for this last item, again, the first step is to isolate everything to one side. So we move 5 to the left side. To do that, technically, we will be subtracting 5 both sides. So we will obtain the following out here. And then like in the first item, since our goal is to combine these two fractions, I left a space out here for us to multiply 4 plus x over 4 plus x. We determine these based on this one. So yeah, combining these two, we will obtain the following. And then from here, let us simplify this expression. So let me do out here. So we'll have here 6 minus 2x minus 5 times 4 plus x. So I begin by distributing negative 5 inside the expression. So we'll have 6 minus 2x minus 20 minus 5x. Then simplifying this, we will obtain negative 14 minus 7x, or I can write this one as negative 7 times x plus 2. So now this time, since we are now able to isolate everything to one side and then simplify it so that it will only consist of linear factors, we can now determine its table of signs. So let us construct that one out here. Okay, good. So to explain this one, this first column out here represents the linear factors out here, and then this one is basically this one out here. And then next, the top row out here represents the real number line divided into 3 regions divided by negative 4 and then negative 2. Again, those were determined based on the values that would make these two zeros. Those values are called critical numbers. We have here negative 4 and negative 2. So again, like earlier, we first determined wherein these two values will be 0. For the x plus 2, that will be 0 out here at x equal negative 2. And then for 4 plus x, that would be 0 at negative 4 out here. And let's determine the signs for this first one. Here, a good test value is negative 5. Because it is less than negative 4 and it's the closest integer to it. Plugging in negative 5 out here, we'll have negative 5 plus 2, that will be negative. 4 minus 5, that will be negative as well. So we'll have here negative and negative. And then based on these marks, we determine that the second column will have here negative, positive, and then the last one will have positive, positive. So now let us determine this part out here. So the common error out here is just focusing on these two and thinking that they divide numbers that consist these signs, but that is wrong since our goal is this one out here and we have a negative sign out here. So since we have a negative value out here, what happens is that we have here negative divided by negative, that will be positive, so that just corresponds to the sign for this 2 times negative out here. This one will actually be negative. Doing the same for the last 2 columns, we have here negative divided by positive, that will be negative, times negative out here, that will give you positive. And then lastly, positive divided by positive, that will give you positive, times negative will give you negative. And then from here, let's return to the main goal of our problem. Our main goal is to determine when will this one become less than 0 or negative. So that happens in these 2 intervals out here. Do we need to shade these 2? Not anymore, since our goal is just less than and never equal to. We don't really need to shade any of these 2, which means that the answer for this problem is given by x less than negative 4 or x greater than negative 2. Or in interval notation, it is given by the following. And these 2 will be our final answer for this problem. That's basically it. So we have dealt in this part rational inequalities. So we had 3 examples, and you might be wondering, is it always just like this big of a table of signs? Actually, it can be bigger. Like if we have, for instance, x minus 2, x minus 1 all over x plus 3. You'll be needing more rows for this one. So we'll have another linear factor out here, and probably more columns since you'll divide the real number line more. But I just dealt with a smaller case, but the idea is just the same. So for the next video, we'll be dealing with absolute value inequalities. So yeah, that's it. If you have any comments or any suggestions, feel free to comment it down below, or you can check the Google form that I have put in the description or the comment section down below to help me provide you better math content that is catered to your needs. So yeah, that's basically it. See you in the last part of this series on inequalities.